Good morning, good evening, good afternoon, everyone, based on your time zone. Welcome in Salesforce FX Hour. My name is Amit, and today we are going to talk about unified developer experience. And we have a great speaker from the Salesforce team, Flip. Let me hand over him for the presentation and the session. Hand over to you, sir.
Yes, thank you so much for having me. My name is Philippe Ozil. I'm a developer advocate at Salesforce. I've been around for about 8 years now. And today I'm going to talk about how you can integrate Salesforce with AWS. And the name of the feature or the set of features that we use to do this out of the box is called Unified Developer Experience. I'm explaining this because it's not always very clear what this means, but Unified Developer Experience is the umbrella term for everything that lets you connect between Salesforce and AWS. All right, so today we're going to see a short number of slides and I'm going to attempt something. I'm going to do a live configuration. So we'll see one of these features being set up live. If everything goes well, you should see one of these things working. So before I jump into the presentation, quick reminder that TDX, Trails ZDX, I should say, is open right now. So if you want to attend, check it out online. There's still some tickets available, so make sure you try those out. There will, by the way, be a Unified Developer Experience booth among the very large number of booths we have. So if you want to learn more about this specific topic, it is present on site at TDX. All right, before now I jump into the technical part of the presentation, I'm a Salesforce employee, so I have to give you the forward-looking statement. You need to make your purchasing decisions based on what is commercially available in the product and not on any things that I may tell you about that are not yet released. Most of the features that I'm going to cover today are already part of the product, but there are a few things that are still on the roadmap, so bear in mind that these may not come to production soon. Now that we covered the legal part, let me jump into our topics today. We're going to see two types of integrations with AWS and Salesforce. The first one I'm going to talk about is data integrations, and we'll see different options we have to integrate Salesforce with AWS data sources. And what we'll spend most time on is the event-driven part. So the second part will be event-driven integrations, and we're going to see how we can do bidirectional event-driven integrations. So sending events from the Salesforce event bus to AWS and the reverse operation, sending events from the AWS events bus back to Salesforce. So that's our agenda for today. And let's start with data integrations. For data integrations, there's something that exists in Salesforce, and it's not specific to AWS. It's called Salesforce Connect. And the way Salesforce Connect is that it works in a sense. Sorry, I just realized that I've written visualization. It's actually data virtualization. So ignore the slide here. There's a little typo. It's data virtualization. And the principle behind data virtualization is that it appears like the data is part of your Salesforce work, but it's in fact an external data source. And there are a number of adapters for Salesforce Connect. The first one, I believe, was for Heroku. So there's the Salesforce Connect or Heroku Connect that lets you integrate with Heroku, but there are a number of other adapters. You can use, for example, adapters to connect to other Salesforce orgs. So within an org, you can connect to another external org. You can use custom Apex adapters. So if you want to connect to whatever data source you want, you can build your own adapter with Apex code, which helps you visualize data from another source. For example, I recently played with it and I made a little integration with GitHub. So I could view, for example, GitHub pull requests and GitHub issues as if they were part of my Salesforce org. So you would see basically a record page or list views of those issues and pull requests. And there's a set also of OData adapters that are available, and these OData adapters are working with a standard, so it lets you connect with external data source and expose OData. Now, these are the adapters we had in the past, and what's really new with AWS is that we now have a set of adapters for AWS services. There are in fact 3 of those adapters that we offer. The first one is for Amazon DynamoDB, and then we have Amazon RDS and Amazon S3. And we're going to see in detail what these means and how this service works. You'll see that there are some pros and cons to using these different services. Some have limitations, others don't have. But one thing that is extremely important about Salesforce Connect is that it's data virtualization and it's also zero copy access. This means that we never replicate data from the external data source. We make it look like it's part of your Salesforce org, but we never copy the data itself. You're just visualizing it, and beneath this view or beneath the different operations you have, we are in fact calling APIs via the adapter via Salesforce Connect. And this goes just beyond pure views. You can use data in reports and dashboards. You can use data with the REST APIs. You can use data in Apex. So it really is the full set of Salesforce features that mimics as if you were using Salesforce records, normal records. One thing that I have to mention, I will not talk about pricing or licensing, but I do want to mention the fact that this is a paid-for feature. It's available in developer edition orgs if you want to try it, but there are some limits in terms of what you can use when using this in production. These are paid-for features. So now I'm going to focus exclusively on AWS. I won't cover much more in detail the other adapters, and we're going to see the different data sources and the different options we have to connect to AWS. So I mentioned there are three different types of adapters we can use to connect to AWS: DynamoDB, Athena, and actually something called GraphQL adapter, which is a bit more flexible. For now, it's only one data source, but it will expand to additional data sources. And I want to compare them a bit so that you understand their advantages and their limitations. The first one we can use is DynamoDB. Now, DynamoDB, for those of you who are not familiar with this, is a large NoSQL database. And if you're not familiar with NoSQL, what it means is that it's a different structure of database. It's not a relational database. It's a single table design. So you have an extra large table with as many columns as you want, but there are no relationships in this table. So it's very powerful because it works with super high scale use cases, billions of records, but it means that you have to spend a lot of time considering the data structure in there because you won't have any relationship. So the design of the data structure is extremely important, and that makes it very interesting because it works great for storing a lot of data, typically auditing or historical data, because the database can grow up to incredible size, but there are some limitations when you use it with Salesforce Connect. The first thing that is important is that you can do read and write operations. That's fine, but since the database is so large, you can't use Salesforce Connect for reporting on Amazon DynamoDB. So it's important to remember that if you want to do reporting, you'll probably have to use another reporting tool outside of Salesforce, maybe, or even maybe Tableau, but you can't use the Salesforce Connect adapters to do reports and dashboards on Amazon DynamoDB. So interesting database, very good for large scale, but maybe not the most flexible if you want to do things that are transactional with a complex data structure. So when you want something a bit more modular, you can try to go for Amazon Athena. Now, Amazon Athena is a slightly smaller database, although it can work with a lot of data. And what's interesting with the Salesforce Connect adapter for Amazon Athena is that it translates our SOQL language, the Salesforce Object Query language, into SQL, standard SQL. Now, this lets you query against a number of data sources, and the typical use case for Athena is storing this data in S3 buckets. For those of you who don't know what S3 is, there's a lot of terminology on the Amazon side, but S3 is a data store that works with a file system. So you can basically store data in an Amazon S3 bucket and query it with Amazon Athena. So it goes from SOQL to SQL and then to S3. And this is really interesting for operation data lakes when you have a lot of data in there and you have some data that changes a bit. However, when we talk about using Amazon Athena with Salesforce Connect, there's a very big limitation. You cannot do write operations. The reason behind this is that S3 doesn't support transactions, so we've disabled write operations. So that's a big limitation. You can only use Amazon Athena to do read operations. However, you can do a lot of read operations. You can even use reports and dashboards for Amazon Athena. So this can be interesting in some cases. The last solution I want to talk about, and I think it's probably the most flexible, although it does require a bit of setup, that's the GraphQL adapter. And you may notice that we were not even talking about an Amazon technology here in the header. Well, that's because, in fact, behind the GraphQL adapter, there are a number of Amazon data sources that can be queried. For now, we only work with one type of Amazon data source, but we plan on the roadmap to expand it to other data sources. The first one that works right now, it's called Amazon RDS. RDS stands for Relational Data Store, and essentially it's relational databases. And Amazon RDS works, in fact, incorporates a number of relational databases. The typical ones you can think about: MySQL, Postgres, MariaDB, and a bunch of others. And right now, what we support for our GraphQL adapter is Postgres. Now, of course, Amazon likes to rename things, so Postgres is not simply named Postgres, it's called Amazon Aurora. So when you see Amazon Aurora, well, think it's Postgres. And what this means with this adapter is that you can have essentially a Salesforce Connect adapter querying a Postgres database on AWS. That's the very simple translation of all these keywords. Now, behind the scene, there's a bit of an infrastructure to put in place. There's a number of services you need to deploy. All of this is well documented in our help sites and the Amazon documentation, but we don't directly query the Postgres database. We have to put a number of things in front of it. We need to use a service called Amazon AppSync, which helps us expose an API endpoint. And then we have to use an Amazon Lambda behind it to basically expose a GraphQL endpoint. And this GraphQL endpoint will transform GraphQL requests into SQL requests that will in turn land on the Postgres database. So that's pretty powerful because Postgres was already well supported when we had the OData integration for external data sources. And now we can also use all of this through Amazon as well. This is the most flexible data sources we can work with because it supports read-write operations, and you can also do reporting. So really, that's in a nutshell the different options we have for integrating data with Amazon. Right. So I'm not going to have enough time today to show you a demo of this. I will spend more time in the second chapter of this presentation, which I'm going to cover now. I'm going to talk more now about event-driven integrations, and I want to talk about how you can do bidirectional event integrations between Salesforce and AWS. So to integrate with AWS, you have two things. And in fact, if you want, you can deploy only one of these two things. You can go, you can build the integration in one way or the other, or both ways if you want. The first type of integration option that is available is from Salesforce Event Relay to Amazon Event Bridge. The Salesforce platform has something called the Salesforce Event Bus, and this is typically what exposes platform events or change data capture events. And on the Amazon side, they also have their event bus, and it's called Event Bridge. Now, the technology we use on the Salesforce side to make these two things communicate with each other is called Event Relay. And you can see it in the graph below there. The Event Relay here is what helps you do the jump from the Salesforce Event Bus to the Event Bridge system, which is the equivalent of the Salesforce Event Bus, but on AWS. So that's the first integration type. And you can do the same thing in the other way around, from Amazon Event Bridge back to Salesforce. And to do that, we use a number of things. So this schema is important because we're going to see how these different elements work together. And I'm going to describe this now in a step-by-step manner. So let's first start from sending events from Salesforce to Amazon Event Bridge. The first thing you need to do that is to prepare your events. So you can send any kind of events, either platform events or change data capture events. So you have to build them or register them first. Once you've done that, you need to create something called a custom event channel. Now, I don't know if you're familiar with this, but custom event channels serve to essentially group events together. And so you're creating some sort of meta event that can incorporate either one or multiple events at the same time. So for example, you can use a custom event channel to group 10 different platform events together and subscribe to only one thing. You can also group a number of change after events within a custom event channel. One thing that is important to note is that custom event channels cannot mix the two types. So you can have custom channels for platform events or custom channels for change events, but you cannot have both types in the same custom event channel. So we decide to create a new custom event channel. And then for this channel, you will register a number of members. And so this is basically a, a I'd say a relation, a so I'm struggling to find the word, yeah, member. You just declare members on the channel. So you say this platform event is part of my custom event channel. Now, the reason why I've separated these things is that you have to do some API operations to create the custom event channel and create the custom channel member. We'll see later on that there is no user interface and setup to work with these two metadata types. So you have to use the metadata API or tooling API to register your event channels and register the members. And I'm going to show you how you can do this next. So once you have your custom event channel ready with its members, either one or multiple members, you can move on to the next phase. The next phase is preparing a name credential. Now, I've specified that this is a legacy name credential because you may have noticed that there are now two types of name credentials on the platform. There are the next generation name credentials, which are used for integrating with Amazon, but with the data services. And then there's the legacy name credentials, which are used for pretty much anything else. And in our case, it's also used for integrating with Event Bridge. So we specify a name credential legacy type that maps to our AWS account. Finally, the last step is to prepare an event bus. Sorry, it's not the last step. One of the next step is to prepare an event bus on AWS. And the way this works is that there are multiple event buses on AWS. On Salesforce, there's only one event bus for your org, but on the AWS side, you can declare multiple event buses. So you have to go into your AWS console and prepare an event bus. Once you have your event bus, you're going to register a partner event source. Think of it a bit like a connected app. It's kind of the equivalent of a connected app, but on the AWS side. And so there's a partner event source that is specific to Salesforce, which explains to AWS how it can integrate with Salesforce. So you register this partner event source, and finally you regroup all of this together with an event relay. And an event relay is you'll see a set of options that link together the custom event channel. So that's the events you want to send to AWS. The name credential that defines what is your AWS account for which you want to target, and the partner event source, which is tied to your event bus on the AWS side. So where these events will be published. So it's a lot of boxes, and you'll see that it's a lot of different configuration screens, but I wanted to highlight all of these different steps so that we understand a bit the architecture. Of course, you only have to do it once. After that, it works silently behind the scenes, and it will transfer the events out of the box. It looks a bit impressive like this, but it actually takes between 10-15 minutes once you're familiar with the process to do all of these steps together. And that's what I'm going to try to show next. Before I jump into the demo, I'll just cover the other thing I want to show also as part of the demo. That's the reverse operation, so sending events from Amazon Event Bridge back to Salesforce. And after that, I'll try to put all of this into action and yeah, deploy this. So let's take a look now at the reverse operation, sending events from Amazon Event Bridge to Salesforce. How do we do this? First of all, we start with an AWS event bus. You can create a custom event bus, or you can use an existing event bus on AWS. Then we create something called an API destination. An API destination identifies an endpoint on our Salesforce org. Now, in this case, we're going to target the Salesforce REST API to create a platform event, for example. And so we're going to be using this Amazon event bus to create a platform event using the REST API. That's how we're going to proceed. Now, how do we connect these things? So we create the API destination, so targeting an endpoint on our Salesforce org. We create a connection, so think of it a bit like a name credential in Salesforce terminology, and that points to a connected app. So this handles the authentication to our Salesforce org. And then we map the event bus with the API destination by specifying a rule. So basically, for any event that lands on our AWS event bus, we can have a routing rule that defines whether it will hit our Salesforce API destination or not. And that's how it works on the AWS side, right? That's it for the slides. I'm now going to take a couple of minutes now to really show you this in practice. So I'm gonna see, let me refresh my different environments. I want to make sure that everything is still working as expected because obviously things may time out. All right. So it looks like everything is still working. I haven't timed out from my different orgs. Let's see. So I am now in AWS, and what we're going to do is use the Amazon Event Bridge service. I'm going to open this thing here. And we're going to take a look at our event buses. Just close this a bit. I hope it's large enough. Let me know if you need me to zoom in a bit more. Happy to do this if you can see well. Right. Okay. Let me also open on the side the documentation because there's a lot of steps, and I will admit myself, I have done it a couple of times, but I don't know all the instructions by heart, and there's a chance that I may miss something. So I'm going to do a little bit of cheating. I'm going to also look at the documentation on the side to make sure that I don't miss a step. All right. I'll also share, of course, all of these different resources that I'm using. I have a nice QR code with a trail mix with all the resources that I'm using, the documentation, samples, and everything. All right. So the first step that we need to perform is creating a platform event. Here, I'm going to show you how you can send a platform event to AWS. I saved a bit of time, so I did this ahead of the demo. I've created a sample platform event. Let me zoom in a bit. Oops. I've created a sample platform event here with just a simple message field. So simple text message. Very simple, nothing fancy here. Remember that you can also use change structure events, but I've used a platform event here because we're going to be also able to trigger it from AWS. So that's the first operation we need to do, creating an event if we need to. The next step is to create a name credential. So I'm going to go in my setup. I'm going to go for name credentials. I'm going to create a new name credential. So now pay attention to this. When you create a new name credential, you have to click on new legacy. Remember I mentioned that there's a next gen name credential. Well, for this event-driven integration, we need to use the legacy name credentials. Things may change in the future. I mean, it's true right now. I don't know if in the future it will change. Now, for the label, we can type whatever we want. So I'm just going to say AWS, and well, I can pick this. That's my instance. I'm based in France. So I'm using the West free instance. Now, for the URL, that's important. We need to take our AWS account. So the format of this is the following. I'm copying from documentation. It's RAN, which is the protocol for AWS, and then the name of our data center. So here, sorry, the data center, the region, that's the name. So EU West 3 is my region, followed by here our account ID. So this is something I can find in my console here. For example, I grab it here. That's my AWS account ID. So I'm going to replace this here. There we go. And that points to my AWS account. Now, let me check. So that's it. Yes. Keep generate authentication token. Yes, and that's it. So that's the first step. We've created our name credential. There it is. Once we have our name credential, we can go ahead and create the custom event channel. Now, I mentioned that to create an event channel, there's no user interface in setup, so we're a bit stuck and we have to use a tooling API or the metadata API. Now, there's some good news. We've prepared a number of requests for you in the Postman collection that we use for Salesforce. So if you're not familiar with this, Postman is an API client, and we've prepared a set of requests in something called the Salesforce Platform APIs. And among those different request template, there's a set of requests for Event Platform, which helps you create the custom channels. It also helps you control the event relay configuration programmatically if you need to do this, but now there's a UI setup, so you won't need this part. Okay, now that I'm in my collection, the first thing I need to do is I'm going to get a new access token to authenticate. This opens a browser, so let me share it with you. Well, you're not seeing it, but it's on another one of my screens, so I'm accepting the authentication using my instance URL here and using my token. That's it. I'm gonna select my instance URL here, but I just copied. This is my demo org, and I'm gonna save it. Okay, now this is all I need to do to authenticate. Let me double check very quickly that this works. To do this, I'm just gonna run a simple REST query for my limits, for example. Clicking send, and I get a 200 OK. This means that I'm authenticated and I can see that I've achieved my limits for my org. All right. Now that we're authenticated, I'm going to be using the REST API, but the requests we want to look at are part of the events platform folder here. And what I'm gonna do is I'm gonna go in the custom channels, and I'm gonna create a custom channel that holds platform events. I'm gonna create a channel, and here I have to do a bit of configuration. I'm gonna go in the body of my request, and here there's already some sample data entered in here. I'm just gonna rename this. So I'm gonna do sample channel, and sample channel is fine. So that's the first entity we need to create. That's the channel itself, and then we'll have to add members. So I'm going to click send, and there we go. It worked. So 201 created, and we got an ID here for our custom event channel. Now, this channel without member is useless. So the next step is to add members to this channel, and we're going to tie some platform events, like sample platform events, to our sample channel. So I'm going to prepare the request. Again, there's some sample data in there, which is not really important for us. So I'm going to just go in here and change this sample channel and sample event here. The naming is totally up to you. You can enter whatever you want. I'm just there. Simple. And that's my sample platform event. One thing that is important, however, is that the name here in my event channel matches the one I've used before. So actually, let me fix this. I need to make sure that the name of the channel matches here, right? So this is my, this one here is my parent channel, and this is my target platform event here. I'm gonna go and click send, and that's it. We have a member on our custom event channel, right? So that's all you need to do with Postman. You can use any other API clients, but remember that there's no UI in setup to do all of this. So I'm going to go back now, and we can get out of Postman. We won't be using it next. So we have, to sum up, we have created a platform event, we've created a name credential, and we have prepared a custom event channel. 3 things we did. Now, that's it for most of the configuration on the Salesforce side. Now, we need to go and switch to AWS now to finish our setup. So the next step is to go in our console here, and I need to register a partner event source. And you can see that AWS integrates with a number of third-party sources, and among these sources, we have Salesforce. So that's the one we'll be using. I'm going to click on Setup here, and from there, I'm going to be able to set up my event source. So now, what else do I need to do? Check. Wait, change method. So we have, I forgot what's next. Sorry, I'm looking at documentation at the same time. Again, I'm not doing this every day, so I want to make sure that I don't go too fast. Yeah, event relay, create prerequisite items. Yeah. All right. Okay, so actually I just forgot one thing. We need to go back in our setup and we need to prepare the event relay. We will register the partner source after. So here I'm in setup, going event relay, and from there I'm going to click new event relay. I can name it, so sample oops, event relay. There we go. Click next. For the name credential, I'm going to pick the name credential I just created earlier. There we go. Click next. For the channel, I'm going to select the channel we just created, sample channel. Next. Then we have the options to handle errors. We'll keep it to the default, only retrieve next events. We're skipping events that we have may have missed. It's up to you to pick whatever you want, whether you support replaying past events. And finally, that's it. We can save our event relay. Now, our event relay at this point is not going to be active. What's important is to look at the status part here. It's stopped. It is stopped, but it's already available for querying on the AWS side. So if I go back now to my AWS console, and if I go in my overview, where is it? In my partner event sources, I will be soon able to see, where is it? I'm going to be able to detect my event source in a couple seconds. Let me see if I can. Yeah, let me wait a bit. I need to wait a couple seconds. So let me refresh this thing. No, it's still not. So I've created the event relay. Let me see. Should I start yet or not? Yeah, so I need to wait a bit. I need to wait for a couple seconds for this thing to populate the partner event source name. When we create the event relay, it's going to query the AWS services, and it takes a couple seconds or a minute to populate the partner event source. So I'm just going to hit refresh, and hopefully, yes, this time we have the partner event source here. So the way this works is that essentially you have uh, this part is always the same. Here, that's an identifier for org, and here, that's an identifier for our event relay. Of course, you can have more than one event relays for a given org. Now that the event relay is activated and registered as a partner event source, we can actually select it on, on the AWS side. So let me refresh this thing, and we should be seeing, yes, here it is. We can now see our event bus, or Salesforce event bus, or Salesforce event relay. So this is the one we need. There's only one, but if you had multiple, remember to pay attention to the parts here, org ID and event relay ID. So for us, we're going to pick this one, and we're going to associate it with an event bus. Let me double check the permissions so that I don't mess up. Now that we have our event relay, we want to activate it. And okay, we don't associate. Yes, I'm not going to check anything. I'm going to leave the default right now, and I'm going to click on associate. That's it. Our event bus is active. Now, when we go to the next step, we can start the event relay. So I'm going to go now back to Salesforce. Oops, sorry, wrong side. Here we go. Our event relay. There we go. And I'm going to start it. So I'm going to go in edit, and I'm going to change the state to run. Let's click save. And it may take a couple minutes. So you can see now the status is starting. So this is the part where it will connect with AWS. everything goes well in a couple minutes or seconds, hopefully it will start. So I'm going to click refresh here. We may need to refresh a couple of times for this to work. I think there's probably a minimum amount of time we need to wait before clicking refresh, but it's starting up. And at some point it'll be written that it's started. Now, once it is started, we're going to try to fire an event and we're going to see if this works. What's interesting is to look at the last replayed field here, which will indicate the last replay ID once we have managed to fire an event. All right, while this is working, I'm going to prepare the setup instructions for firing an event bus. And I'm going to do also another thing. I'm going to actually let me switch my view. I have multiple windows. I'm going to prepare a let me hide this thing. There we go. I'm going to prepare another view on my org, and I'm going to prepare a tool that I love to use for working with event-driven integrations. That's the Streaming Monitor. The Streaming Monitor is an app that I built and I put on the App Exchange, which essentially helps you to capture events, platform events, or change data capture. Why? Interesting. There we go. Streaming Monitor. So it's just an LWC app. But with this app, I can subscribe to events. So here I'm gonna subscribe to my custom platform event, my sample platform event, no replay, and that's it. So here I'm listening to my platform events. I'll keep this window on the side, and it will show a little pop-up when we receive our platform events. Let me see. Yes. Now you can see my event relay is working. All right. So on the Salesforce side, we're ready. Now, what we want to do now is to fire a platform event on AWS. To do that, I'm going to go back into my console here, go on my event bus. Here I have my event buses. So for the event buses, we have two of them now. We have the default one, which is pre-existing by default for my account, and we have a new event bus that was created with my partner event. So this event bus is specific to my event relay, to my platform event. So I'm going to select it, and what I'm going to do next is I'm going to use it to fire an event. Let me check now how I can do this. So I click on my event. I need to create a rule. All right. So before I can fire an event, I'm going to need to create a rule. And let me see, create rule. Yes. I need first to select my event bus. There we go. I'm going to create a rule. Just called sample P, fire sample P. Then my event bus is already selected. And what should I do? For rule type, I can use next. For the event source, I can pick AWS event or event bridge. That's the default one. For the sample event, event bridge partner events. And here you can see that I have a number of pre-made templates here for Salesforce. I could use one of these, but I'm going to fire, instead of firing these account change event or opportunity change event, I'm going to write my own. So I'm just going to type in a bit of text here, and I'm going to do Salesforce. I can keep that thing here. And for the, actually, no, no, I don't want to use this. Can I cancel this thing? Let me just delete that thing. No. Let me leave it like this. Okay. Now for the, I should have skipped this. Sorry, let me go back. I just not select. I can't go back. Damn it. Let me say enter my, okay, never mind. No pattern. Okay. Now for the creation method, event source, event which partner. That's sales. I'm gonna go quickly with this because you can read all of this, of course, from documentation. There we go. Event type. Okay, this one is not listed. Uh, And here I can say all events here. That's it. So that's a default pattern that will take any event that is going to be fired to Salesforce. Can click next. And finally, in the target part, I need to copy a bit of text here. Custom. Second, just realizing that I may have missed something. Yes, did you miss? Let me double check one thing on previous screen. It's important. Custom pattern. Sorry, I missed that. Okay. Yep. Custom pattern. I'm copying from documentation. I'll fire myself. Of course, this is optional. This is just to verify that my configuration work and fire manually my event from here and take the target. Oh, sorry. Database service. This is just logging the events. Ah, it changed documentation, but okay, let me. Okay, next. There we go. Okay, now let's try to see if I can fire my event. All right, I have my partner event source, and I'm gonna try to see if I can fire my event. Let me check. Okay, so let me see if I can make this work. Now my what I did is that I created a rule that will send my incoming platform events and put them into a log watch, which is a service that just basically writes logs on AWS. And if I did everything well, we're going to see in the traffic of my bus some incoming events. So here, for example, in the monitoring, we'll see an event incoming when I fire my platform event. Let's see now if I can fire it. So I'm going to go back in my where is it? In my org here, and I can also use the streaming monitor to publish an event. So I'm going to do that now. I'm going to fire my custom sample platform event. I'm going to put a little message. So this is just the JSON that describes my sample platform event. So I'm just going to say hello from Salesforce. And I'm going to publish it. Now, of course, I've received it directly within my org, but normally now we should see in our event relay configurations. Actually, let me just increase this a bit. If I do a refresh, we should see something here coming in the last replay. That's the last event we replayed. So we did capture the event, and let's see now on the AWS side if we did receive this thing. So I don't know if okay, this is not showing up, but normally if we go in CloudWatch, we should see in the log groups, sorry. We should see in my log groups, my log group. Yeah, we go. We should see, yes, a new event being received. I'm going a bit fast because I see that time is running out. But here, this is our custom event. Here you can see the message we just received. So we capture the event with Amazon Event Bridge, and we routed it to a log called my group log. And you can see that's our payload here. This part is the part that represents our platform event. The rest around it is metadata added by Salesforce and the integration with AWS. Right? I'll show you more of the details on this, but if you have platform events or changes and capture objects, they're going to be showing up in payload, and you'll see the custom fields in there. Now, very quickly, I see the time is running out. I'm going to try to show you how we can do the reverse operation. So that is firing an event from AWS and receiving it back in Salesforce. So I'm going to exit CloudWatch. I'm going to go back on Event Bridge. And this time, we're going to see how we can do it. So let me just quickly go and open the right docs. So, too many windows open. The first thing we need to do is to create a connected app. So very quickly, I'm going to create my connected app here. I don't know if I'll have enough time to do this, but I want to try and show you how this works. App manager. I'm going to create a new connected app. And this is helping me. So I'm going to call it AWS, just simply AWS to go very quickly, email, whatever. I don't need to fill any of this. I need to enable OAuth settings. And what is I need to enable for device flow. There we go. For OAuth scopes, I need the API access. Let me see where it is. There we go. Yeah, this one. And if we scroll down, we're going to have to enable require web token. Okay. And I think we want to enable, yes, we want to enable the client credential flow. So the client credential flow basically is a type of authentication that works from server to server, which basically grants the external server the same access rights as my current user. So that's what I'm doing, and enabling this because I'm trusting AWS to act on my behalf. Now, what I'm going to do next is not really something you should do yourself. I'm going to be using my own administrator account. Obviously, in a real-life production scenario, you want to take a user with less access rights. Now that I'm done, I'm going to click on Save and wait for the app to be created. Of course, this takes a bit of time, so I don't know if we'll have enough time to showcase this. I may be jumping back to the slides as the app is being created. One thing I want to do next is I'm going to have to go and get my my secrets. I will also want to specify which user is the one that is being used for managing access. So I'm going to go in here. I'm just going to hide my window just for the sake of security so that you don't see my secrets. Let me get first my verification email. So hold on a second. I need to verify my identity. Just doing that now. And I have my consumer key and my secrets. I'm going to keep them on the side because I will need them later on. I will continue the instructions, the setup. I need to go now in App Manager. I need to take my AWS app here. And I think I need to go in Manage. I'm going to go in Edit Policies. And there, I need to specify who is my handler. So which user has, for which users I'm taking permission. So for this, I'm just going to take my own user, Cody the Bear, which is my org administrator. Again, don't do this in production. Take a user with less access rights. So I'm saving this. And while the app is being set up, let's not waste too much time. I'm just going to go very quickly with the last few slides I want to show you. And spend just a second showing you this important bit. So we saw this is what we're going to do next, the setup we're going to do. So I'm not going to go over it again. But one thing I want to show you is for integrating with events, you don't get exactly the same data. The payload is the same, but the metadata is different. Here I have a side-by-side view of what you can see in AWS and in Salesforce when you integrate with events. The part in red is the core of your message, whether it's a platform event or a change data capture event. This is the payload. Now, there are a number of things that are either identical or different, and I'm going to call those out now. One thing that is important on the AWS side, you have in your source, that's the name of the bus, the org ID first, and then the custom event channel ID here. Then you have your event name, and it's called a detail type on the AWS side. So remember this, detail type means the API name or event. Sample Eve, it's the same example as we were using right now in our demo. Then the other thing that is important, that's the event schema. The event schema is basically a snapshot of the structure of your object. So for example, if you have a platform event with a set of fields, this corresponds to a specific schema ID. But if you start modifying your definition of your platform object, of your platform event, sorry, if you add a field or delete a field, the schema ID will change. So that can be important in some cases if you modify the structure of your events. And these two things matches. However, one is named schema on one side, the other one is named schema ID on the other side. So be careful about this small difference. Then, and yeah, the other thing I want to cover is that you only have the replay ID on the Salesforce side. You don't have the replay ID on the AWS side. I didn't show it in the slides here, but here you can see in event reply ID. This part here is not showing up on the AWS side. So it's important if you need the replay ID, it's not going to show up here. Right. Before I show the last slide with the resources, I'm going to try to finish my configuration. So hopefully the connected app is now deployed, and I'm going to be able to move on to the next step. The next step to prepare my Amazon event bus is to create an API destination. Remember, I'm actually having to register a Salesforce REST API endpoint. So I'm just going to put Salesforce REST API. That's going to be my name. Skip the description. And then I'm going to paste the target URL. Getting back to documentation. So this should be the endpoint for creating my custom events. So let me just copy the sample from documentation. It looks like this. I need to replace obviously my domain name and the API endpoint. So in my case, it's the sample platform event. Notice that it's under S object, so you can create a record in the same way that you can create also a platform event. It's kind of a record, except you can't read platform events from the REST API, obviously. For my event, for my endpoint, I can just copy this here. I don't have it. That's my domain name. Replace this in here. Oops. That's my org name with my input, right? HTTP method, we're going to use post because it's for creating a record. We don't need to specify anything else here. We just need to create a new connection, and this is where we'll set up authentication with our Salesforce org. So Salesforce org, I'm going to name it Salesforce org. There we go. It's going to be a partner source, I believe. I'm going a bit fast from my memories, partner, then I select Salesforce in here. There we go. Or client credentials, it's fine. The endpoint for logging in, we're in a developer edition, so that's login.salesforce.com. HTTP method is post, and then I need to enter my client ID, a client secret. So that's what I saved on the side here. Where did I put them? Here we go. Hopefully I haven't made any mistakes. Go. Next, for grant type, we are not going to use the password grant type. We are going to use something else. We are going to use a client's credential grant type. So that's the client credential authentication. We don't need those extra things here, just this. Then in the invocation parameters, I think, let me check, I think, oh, that's it. All right, I can create it. Oh, doesn't like the space, I guess. Right, fine. I'll remove the space then. And then create it. No, it's also not happy with the space here. So same, I remove the space. And there we go. Okay. Now, the way this works is that you can see that my newly created API destination is inactive right now. And if I did everything correctly, when I click on my connection, it first is going to test the connection. You can see here it's deauthorized. And what it's going to try to do is going to test the authentication for me. So if I wait a couple of seconds and I hit refresh, hopefully we should see a green status there. Now, I did this very quickly, so maybe I messed up in my connected app configuration. That's a possibility. If it doesn't work, I guess we'll have to skip this part. But normally, Amazon tries to authenticate using my connected app. And if it goes well, come on. Taking a bit of time. Well, have to wait. All right, while this thing is processing, I'm gonna show you the resource slides. I understand that some of you may be in a rush to leave at the end of the hour, so I'm gonna share some resources and talk a bit about what's in there. So this is a trail mix that we've assembled with a set of resources. It points out to the documentation for the event relay for the different AWS data sources, Salesforce Connect. And yeah, this is all the configuration that you need to deploy. If you want to explore it, remember that you can try Event Relay for free. It's available for everyone. There's no extra cost, except, of course, for the AWS services. So that's actually pretty interesting to try it out. You can try it with a developer edition org. Same goes with Salesforce Connect. The only thing you need to be mindful of is the AWS costs. But you can also try to get a AWS trial account and try those out. That's in a nutshell what I wanted to share today. Let me see if I can get this to work. I would love to leave you with a working demo. Yeah, I don't know if it's gonna work. Still deauthorized. It could be that I mistyped something. Honestly, it's yeah. So normally, if I made something wrong here in the connection, I would see a status reason saying, for example, invalid grant. It would tell me that I have probably entered the wrong client secret or misconfigure my connected app. If you worked with connected app in the past, you'll see that it's very easy to forget to check a checkbox or provide an invalid value. And when you work also with connected apps, you have to bear in mind also that there's a little latency. It can take up to 10 minutes to update settings. So this could be also one of the reasons why this is not working. The connected app may not be fully deployed yet. Well, I don't think we're going to be able to see it. So I am going to take questions. Maybe you have questions. I wasn't able to look at the chat as I was driving through this. So maybe Amit, can you tell me if there are questions while I try to make this thing work? And feel free to
In the
take them.
meantime, if
Yeah,
anybody have any question, feel free to unmute and ask a question
yeah.
directly.
Awfully quiet.
So there is a question from Arun, maybe outside of the scope of this session, but a question: are there any adapter for GCP as well, or only AWS?
Okay. It's no, it's actually it's not completely out of scope because we are right now we're partnering with AWS. We don't have such a partnership with Google Cloud, so nothing for GCP yet. However, when I did cover the different Connect adapters, you could theoretically make your one yourself with the Apex adapter. It's a bit more work because you would have to deal with authentication, but if you take a look at the examples, like for example, the one I mentioned with GitHub, you could make this work properly with GCP. The only thing that you'll have to do is also configure the service on the GCP side of things. Um, for Amazon, it's pretty easy because there is this so-called event partner source, which has a lot of presets and helps AWS connect back to Salesforce. For GCP, I don't think we have this one. There might be
So,
partner solutions that can do it, however, but nothing native out of the box that is built by
so,
Salesforce.
so there is another question from Varuna. If our Snowflake data is in AWS/S3, can we use Salesforce Connect Amazon Athens?
If it's in S3, there's a good chance that you can use the Athena connector, I believe. Yes, I think it's Athena. Let me check. Uh, yeah, the Athena connector. So it would be worth giving it a try. Yeah, because it's supposed to be able to read S3. Now, again, remember that it's read-only, it's not write.
There is another question coming from the event bus to Salesforce. Instead of using REST API, can it be PubSub APIs?
Not, no, I don't think so. The reason why I mean, not out of the box. The solution we have right now goes with an API destination. Now, if you could work with the PubSub API if you were to create your own Lambda, which connects with gRPC directly to the PubSub API. So you could. It's probably a bit more work because you have to write custom code. The solution that I want to show today has zero code. So you could use the PubSub API if you wanted to, but you would have to create a custom Lambda with a PubSub API client. Uh, we have a number of those available in the language of your choice, Node.js or whatever. And yes, you could certainly do that. But I mean, why write code when you don't need to? That's the question. I mean,
Hey, now you can try to unmute yourself, Varuna.
Yeah, I mean, thank you.
sure.
I had another question. So I
Yes.
saw there's an article from Tyson Reed about this new Salesforce event bus.
Yep.
So is this AWS event relay using this new event bus or the old?
Absolutely. So Tyson Green, up till very recently, was the product manager in charge of Unified Developer Experience. And yes, that's exactly what it is. So the naming, again, is a bit, it has different names. So on the Salesforce side of things, we call it Event Relay because this is the technology that helps us to connect to Event Bridge on the AWS side. So Salesforce Event Bus, Event Relay, and Event Bridge. But yes, that's the same thing you saw. All right, I'm not sure if this will work, so I think I'm gonna give up on this, but I think I already did this session at French.streaming, so there might be a version, or actually no, I did also a code live with this. So if you look at the code live on our Salesforce developers YouTube channel, you may see the complete demo with the back and forth demo that I'm not going to be able to show now, but it does work and it's normally pretty simple to do, except this time I was a bit in a rush to do it. 1 hour is short to demonstrate all of this live, but it's really interesting to see it. All right, I'm gonna pause it there, and well, if there's still some questions, I'm happy to answer. And yeah, otherwise I want to thank you all for your attention. It was a full hour.
Hey,
Philippe,
look, you're
can I ask you
speaking on
one
mute.
question? Sorry. Amit, can I ask you one question?
Sure.
Yeah,
Yeah.
please go ahead.
So yeah, so on a platform event, right? So usually you have to define the attributes, right? Say you're creating a account, you have to define the attributes. And assume you have to create a platform event where you want to include accounts and contact, like a parent and child. And sometimes it could be one child, sometimes it could be two children records, right? So in this scenario, how would you handle that when you want
So
to?
the platform event is a very simple data structure. It doesn't hold any relationship. So the way you want to work, if you want to link to other objects, is that you will not try to include the data from the other objects. You will just use IDs, and then the client that is subscribing to the platform event will have to access the Salesforce APIs to load the objects. That's the way you would work. You're limited in terms of volume of information with platform events. You don't want to create an overly complex platform event.
So Philip, I think it'll work when you're doing a read, right? So you have the IDs, you can read the data. But if you want to write to Salesforce,
So if you want to write to
then
Salesforce, what you would have to make an adapter that reacts to the platform event. So for example, you can write an Apex trigger, a flow, or something like this when you receive a platform event.
You were saying don't make an overly complex platform event. How does that apply in the case of change data capture events, which can get pretty complex and layered with multiple records being caught in the package?
So yeah, platform events are really a different beast because they mimic the object for which they're declared. So they all tend to include all the fields. However, the difference is that in the default behavior, change data capture, we only include the fields that have changed. So for example, if you have an update operation, the change data capture event for this update operation only lists the fields that have changed. All the others have a null value, and you have a list of the change fields. It doesn't give you the entire object back. So I think that's a little tricky part. Now, there is something, we're getting a bit out of the scope of this, but there's a feature called event enrichment, which can force certain fields to appear in a change data capture event, even if they haven't changed. I've made a little quick take video for this if you want to see. It uses custom event channels, and you can declare certain fields that will always show up in a change data capture event. That's
That's cool.
important, for example, if you have external IDs, because these IDs are pretty static in times, but you do want to see them when you have a change data capture event, even if they haven't
That's great
changed.
to know.
that's data enrichment, right, feature?
Event enrichment, yes.
Yeah.
I have a short 5-minute video showing you how you can set up on YouTube. So you search for this, you'll find them.
Well, I'm going to drop, but thank you very much, Philippe. This was very
Yeah.
informative, and thanks, Amit, for arranging it.
Yeah.
Thank you so much,
Exactly.
Philip, for such a great session. And thank you everyone for joining us. Stay connected, and who all joined the uh, meeting in between, we'll share the recording with you. Thank you, everyone.
Thanks, everyone. Bye.